I'll just continue from here. The video will just continue seamlessly. I'll just put that part out. So we have question 11. Option 10. Question 10 is option 10. Question 10 is option C. So we have question 11 now. Question 11 says solve the inequalities x squared minus 6x plus 5. It's greater than 0. The first thing is the first thing that you do is to solve the quadratic equation. You solve the quadratic equation using factorization method. You multiply all this, you have 5x squared. So you have to find the factors that by the time you multiply you get 5x squared, and by the time you add them together you get minus 6x, and that will be minus 5x and minus x. Like minus 5x and minus x will give you 5x squared. Minus 5x plus minus x will give you minus 6x. So these are the two factors. So now you have x squared minus 5x minus x plus 5 is greater than 0. You have x bracket x minus 5 minus 1 bracket x minus 5 is greater than 0. You have x minus 1 and x minus 5 is greater than 0. So these are your two turning points when x is equal to 1 and when x is equal to 5. These are your two turning points. And remember, if you are dividing the line, that is the number line, you have these 2 points, 1 and 5. The first step is the step that is less than 1. The next step is the step that is in between 1 and 5. The last step is the step that is greater than 5. So that is going to be the step that we're going to analyze. First of all, x is less than 1. 1 is less than x less than 5. And x is greater than 5. These are your 3 points that are going to analyze. So let's analyze them. I'm going to finish on the board. Yeah. So we have x is less than 1. 1 is less than x less than 5. And x is greater than 5. We have here as x minus 1, if I can still remember, x minus 1 and x minus 5. So what is the sign of x minus 1 when x is less than 1? That is, when x is less than 1, all the values of x minus 1 will either be negative or positive. Let's test that. When x is less than 1, if you subtract 1 from both sides, you have x minus 1 is less than 0. Any number less than 0 is negative. So this is negative. When x is less than 1, x minus 5 will be less than minus 4. So this is going to be negative also. When x is between 1 and 5, x minus 1 will also be a positive number between 0 and 4. So it's going to be positive. When x is between 1 and 5, x minus 5 will be between minus 4 and 0. So it's going to be negative. When x is greater than 5, x minus 1 will be greater than 4. So this is going to be positive. And when x is greater than 5, x minus 5 will be greater than 0, which is positive. So the sign analysis for the product will be positive, negative. Sorry, minus and minus that is positive, plus and minus that is negative, and plus and plus that is positive. So this is what they call it. We're looking for negative or positive. In the question, it says x squared minus 6x plus 5. So we're looking for the positive answer. That is these two states. X is less than 1 and x is greater than 5. So that is going to be option C. Now, why is option C? Since x is less than 1, that means x is from minus infinity to positive 1, not included. Remember the question says greater than, not greater than equal to. So you're going to use curly bracket, not curly bracket, circle bracket. You're going to circle bracket. Union from 5 to positive infinity. Option C. Option C. Okay, the next question now says we should express 7x squared minus 1 divided by x plus 3 as a polynomial plus a proper fraction. Now this question is very much similar to the other question that we had here. There is in the question, I think question 4. Is it question 4? No, not question 4. I think question 5. Question 5 of the test review. Yes, test 2. So this one is exactly similar to that one. So we should now find, we express the polynomial plus the proper fraction. Okay, express 7x squared. 7x squared minus 1 divided by x plus 3 as a polynomial plus the proper fraction. I want to apply, first of all, before I show you, I also want to just make note that this method that I showed you without that video, I think the third method, I feel like that method is actually the best in solving all the polynomial questions quickly. So that's what I'm going to run through first of all. So now we're looking for a way of fitting x plus 3 into 7x squared into 7x squared. So we can expand this as 7x bracket x plus 3. That is forcing in x plus 3 here. And force x plus 3 here, 7x times x will give you 7x squared. 7x times 3 will give you 21x. But there's no 21x here. So you have to subtract away that 21x. Don't forget your minus 1. The next thing now is now also forcing this x plus 3 into this minus 21x. So we have 7x. Wait, since you are already forced in, let me change it from black marker to green marker. Since we already have a green marker for that one. We have 7x times x plus 3 minus 21. Let me change it back to black. Minus 21 times 7, sorry, times x plus 3. So we have 1 times x plus 3 minus 1, all divided by x plus 3. So now, since we are now forcing in x plus 3 here, minus 21 times x will give you minus 21x. Minus 21 times 3 will give you minus 63. Will give you minus 63. But there's no minus 63 here. So don't forget, you have to add minus, you have to add 63, sorry, you have to add 63 minus 1. So you can now divide, you will now start x plus 3 to cancel out here, leaving you with, let me change it back, let me change it to red marker, leaving you with 7x minus 21 plus 63 minus 1, that's 62, divided by x plus 3. So even without solving, or I don't know, this becomes a solution, even without solving, you get the answer is option C. Yeah, that's like this forcing method, which I don't really know the name, but as long as it works, it's maths, as long as it works, it always works, something like that. But I don't know the name, but I think the concept of it usually works like long division. It works like long division. The same way you can do your long division using that train method. The same way you can do long division using that train method, and also do long division as just like give you 632 divided by 2. You cannot do 2 here 1, 2 here 3. I feel like the same way you can do it for here. Then also you can have there's 2 divided by, let's say 17. 179 divided by 2 now. In this case now, you can see that 1 cannot be divided by 2. 1 can be like you need a number that's greater than 2. So you are doing is to force in that division by picking 1 and 7. So that's what this forcing method does. You have 7x squared minus 1. There's no x plus 3 is 7x squared. But you force in that x plus 3 there. You force in that x plus 3. Find out what you need to subtract away to make it balanced again. Then force in that x plus 3 again. Find out what you need to add to make or subtract to make it balanced again. Then just keep forcing it till you reach the place where you cannot force it again. You have 73. You are not forcing x plus 3 there again. Whatever you force in, you have to also subtract it out. So there's no need forcing it again. You can just stop here. And you now get 7x minus 21 plus 62 over x plus 3. Now we know for that I'm going to do the first run of the video using the long division method, which is the actual method you're supposed to have used to solve this question. But I'm just going to show you the short. I'm just showing you the short method. I'm going to do first run the long division method right now. I just passed around the which actually felt faster than I feel like this method actually faster than the forcing method because I just did this faster than I did for the forcing method. But whichever method you feel is faster, you can go for it. But I just did the first one and that same 21x that we forced in also showed here in the this train method. I don't know long division. Yeah, the proper name is long division, not train method. The proper name is long division. This 21x that we showed in that forcing method. It also shows here in the long division method. So I just the same. So you write down the quotient 7x minus 21 plus the remainder plus the remainder 62 divided by the first dividend as x plus 3. So that's option C. Question 12. Option C. Okay. Question 13 now. Which of the following partial fraction identities is correct? If you know the way I honestly dislike this type of question, but because if you have solved some question, you have to solve every single option. But let us go. Is there okay? Actually, there is a more reasoning to this. If you look at all the options, you have 3x plus 5 divided by 2x squared minus 5x minus 3 in most of the options there. That's option A and option C. So you know the correct expression that they wanted to put there is 3x plus 5 divided by 2x squared minus 5x plus minus 3. So you have to just solve that quadratic equation, then compare with the rest. Okay, we have 3x x minus 3 times 2x plus 1. That is using your quadratic, any of them, any of the ways of solving quadratic equation. Either using complete square method, factorize it, or Almighty formula. That's the mouth. Almighty formula. So to break this down into incomplete partial fraction, I feel like the name I gave it in the test 2 review. I call it incomplete partial fraction. You have a divided by x minus 3 plus b divided by 2x plus 1. If you multiply this, you have a times 2x plus 1 plus b times x minus 3. This must be equal to 3x plus 5. Now, let x equal to 3. Then 3 times 3 is 9 plus 5 is 14 is equal to 8 times 2 times 3 is 6 plus 1 is 7 plus b times 0. So b gets cancelled out. If you divide both sides by 7, we have a is equal to 2. Is there need to continue? Yes, both of the options are 2 and 2. So there's need to continue. You need to find the value of you need to find the value of c. Sorry, b. You find the value of b. Find the value of c now. Since you know the value of a, just put in there as a is equal to 2. So now you have 3x plus 5 is equal to 4x plus 2 plus b times x minus 3. 3x minus 4x, that is minus x, plus 5 minus 2, that is minus 3, no, plus 3, is equal to b times x minus 3. If you divide both sides by x minus 3, the x minus 3 will cancel. And if you look at it, you have minus 1 times x minus 3 divided by x minus 3 is equal to b. So x minus 3 here will cancel out. B will just b is equal to minus 1. I hope that should be equal to minus 1. So you put this your two knowledge now, that's a equals to 2 and b equals to minus 1. Back into this incomplete partial fraction, that's the name I use for it. Incomplete partial fraction, you get 2 divided by x minus 3 minus b divided by 2x plus 1 as the complete partial fraction. And this corresponds to option A, 13. Now, just for safe check, remember that option B says x plus 5 divided by the same thing. So it's also possible that that can also be correct. But if you look at that option B now, if you look at that option B now, the quadratic here is the same as the quadratic that is in option A. And the right hand side now, if you look at the numerators, you have x minus 3 and 2x plus 1. You have x plus 3 and 2x plus 1. So that cannot be correct because that x plus 3 times 2x plus 1 cannot give you 2x squared minus 5x minus 3. So option B is going to be wrong. So option A is only going to be a correct answer. But I'm not saying that in case that option B has made a little bit sense, you will have tried to check if that one is correct. Next question now is question 14. Question 14 says you should express x divided by x squared minus x plus 1 times 3x minus 2. I saw this question in the test review, so I'm not going to solve it now. Please go to the test review and check the solution to this question. But if you check the solution to this question, you start option A, B, C, D, and E is wrong. So the correct answer to this question is 14, which is option E, none of the above. 14, which is option E, none of the above. Question 15 now says x minus 4 is less than, the absolute value of x minus 4 is less than minus 2. The absolute value of x minus 4 is less than minus 2. Now, in this question, I first of all almost made a mistake of even attempting it. Until I realized that the absolute value should always give a positive number. The absolute value of the absolute value of x minus 4, no matter what it is, must be greater than 0. But in this case now we have less than minus 2. So there's no solution at all. The answer is none of the above. The answer is no solution. There's no solution to this in the real number. The absolute value of any kind of imaginary number can it be a negative number? Sabola? The absolute value of an imaginary number can it be a negative number? I think so. Can be a negative number. The absolute value of an imaginary number is square root of a square plus b square. Okay, so you cannot so you cannot be so the absolute value of a number, even if it's imaginary or real, cannot be cannot be a negative number, except if some mathematician decides to create a new form of numbers. Maybe there's the real number is imaginary number, and we are in 3D space, so they can create a 3D number. That's third dimension number. Maybe there is there is the real number r, there's imaginary number I, so they can create a new number, maybe H or J, and call that one the number that by the time you find the absolute value you do but for now there is no such thing as a negative absolute value. So we have solution for that something to be C. Something to be C. No solution at all. And I believe they made mention of this in class 20 times that the absolute value of a number not be less than 0. So I believe that brings us to the end of this video. I'm going to put this next video on my hand right now, so you can click this video and go to the next video. What does it mean?